Hi, my name is General Simon. My register number is URK71CS049. Now we are going to see the implementation of stack and queue using linked list. Now we are going to see a sample program for the stack and queue using linked list. Here we are going into the program. Here we are giving a header file hash include bit/std++.h, and then we are giving using space namespace std, and then we are creating a structure called node. In that we are giving data, and then we are giving a pointer to the node of node star next. Then we are creating a class called stack. In that class we are giving a pointer called head node star head. Then we in the public we are giving stack null, stack with null constructor. We are assuming head equal to null. Then we are giving void push stack of int d. Then we are creating a node star s is equal to new node. If head equal to null means we want to assume head is equal to s star data is equal to d, and s star next is equal to null. If this condition must be done if head equal to null. If it's not null means we are creating another new node called monk. We are assuming the monk as head. If that monk is monk's next is null means it want to break. If it's not null means it want to add that new element to the existing element. Then afterwards the same process can be done for each and every insertion. Then afterwards we are giving a void pop stock. In that pop stock we are creating a temporary node and another node called monk. We are assuming monk as head, and then if the monk dot next equal to null means it want to assume temp is equal to monk dot next, and monk dot next equal to null, and then it want to delete the temporary variable, and it want to break statement, or otherwise it should go for the next value. That means monk is equal to monk dot next. And afterwards we are giving void display stack. In that stack we are giving if head equal to null means it has nothing to display, or otherwise it should want to display the remaining elements which is present in the stack. And this is the end of the program for the stack. And then we are going to see for the queue. For queue the same thing, we are creating a head here, and then for the queue we are giving a no constructor here, and we are assuming head equal to null. Afterwards we are giving void enqueue of int d. We are creating a new node. If head equal to null means it want to insert the data. For the insertion we are giving here the keywords here. If it's not means that means we want to insert the element at the first position, or the end, or at the middle, or at any of the desired positions we want to insert. Based on the choice it should be inserted. And afterwards for dq we are the same condition. We are creating a temporary variable here. Then if we are deleting the beginning of the node means you want to make first of all the temporary variable set, and afterwards only we want to delete that variable. For that the condition is given here. And then in the void display queue, if head equal to null means it should print, then there is nothing to display, or otherwise it should show nodes. It should display the remaining elements which is present in the queue. And this is the end of the program for the queue. Then afterwards in the main function we are creating a variable int ch1, and then we are printing implementation of stack, and we are giving two choices, which is first one as stack and second one as queue. And we are checking whether if it's one means you should perform the stack operation. In case 1 it won't perform push. In the case 2 it want to perform in the choice 2 in the stack it want to perform pop, and in the choice 3 it want to perform display, and in the choice 4 it want to break. Then afterwards we are going for the queue. In the queue if we give 2 means it should perform the queue operation. In queue operation we are creating another one switch statement, in which we in the first case as enqueuing the elements, second as dq, and third as display, and fourth as exit. That means we are breaking. Then afterwards we are breaking statement. So this is the end of the program. Now we are going to see the output for it. I am giving first of all for this one stack. I am giving some. It's asking options. I am pushing the element, and I am giving the element to be pushed. and afterwards again it's asking the operations to be done, and I am giving the element. Then afterwards it's asking again, so I am pushing another element here, and afterwards I am popping one element, and afterwards I am displaying. So it's showing me the remaining elements which is present in the stack, so I am exiting and it's accepting. So this is for the stack. Then afterwards, now we are going to see for the queue operation whether it's working or not, and it's asking NQ or DQ or display or exit. I am giving NQ. I am giving the same process which I have done for the stack. I am giving here, and I am giving the same NQ operation here. Then afterwards I am dequeuing one element from the queue, and afterwards I am displaying it, and it's showing the remaining elements in the queue. Then afterwards I am exiting from the statement, so it's exiting. So this is the end of the program for the implementation of stack and queue using linked list. So thank you.